Here's what a laser looks like. This is how a laser works. We have a lasing medium, and the medium is named for the species of atom or molecule that we're going to pump up and then cause that chain reaction. So the lasing medium would be carbon dioxide, and a CO2 laser is also mixed with nitrogen, and there's a two-step process in pumping up the CO2, so you need the nitrogen, or argon gas, or neodymium embedded in a crystal, and the crystal is a yttrium aluminum garnet crystal. So that's why it's called an Nd:YAG laser, and it's solid state. And so we have neodymium atoms in there for an Nd:YAG. You can have different type of crystal, YSGG crystal. You can put erbium in there instead of neodymium, get an erbium YAG. And there are a lot of things you can do in here to tweak the wavelength that comes out. So we put energy in, some energy source. This is a flash, shows a flash lamp maybe that's exciting all these atoms up to the excited state. One decays spontaneously and it starts to laze. You keep pumping them up as they go down to the ground state so that you can keep that chain reaction going. And the photons bounce back and forth between these two mirrors. This is called the optical cavity. Two mirrors facing one another and all that lasing going on in there. One mirror is partially transmitting, shows a 10% transmission. This comes out as a laser beam. And not only that process collimates the beam, but the parallel mirrors also collimate it. Anything going off, scattering off to the side is absorbed in the wall of the cavity. So you get an intense beam of light coming out where all the photons have the same wavelength and they're all moving in the same direction. It's collimated. Also notice that in this diagram, lasing is more efficient in the center of the cavity than at the edges. So you end up with a beam coming out that looks like this, which is called the Gaussian or normal or TEM00 mode. And it's the mode that FootLaser works in too. So what you see coming out of the optical fiber is a profile of the beam that's Gaussian like this, where it's more intense in the center and it falls off to infinity on the outside. So that's the basic component of a laser. All you really need to know is this part, plug it in, and this part, this is what hits the tissue. And don't mess with this stuff because you'll electrocute yourself if you go in there.